This is the same problem. We're going to solve it by the method of joints, but instead of tracking sines and cosines, I'm just going to keep track of x and y components, and it's easier to show this by an example than by trying to explain it. So here we go. Let me put in the reactions. This one was 20. This one was 16. I did double check them. Those are correct. And it's still the method of joints, so we still start with the same step of putting in everything that we know. We know that 12, this is 24, that reaction over there was 16, and this one is 20, and this X reaction is 0. We'll do the same thing. Look for a joint with only two unknowns, which is, again, is joint A. And we're going to draw the free body diagram. Here we go. There's that 16. And let me draw these two forces. Now, this is where things are going to be a little different. This force here, which is FAE, has a y and an x component. And can you see that by adding forces in the y direction, this y component has to be 16, right? What we wrote before was FAE times 0.8 plus 16 equals 0, and then we solve for FAE. Well, what I'm doing, okay, so let me just write out the equation. Sum Fy equals 0, and I had 16 plus FAE times 0.8 equals 0. This right here is the y component of FAE. Now, obviously, for that to be 0, this has to equal minus 16. 16 plus minus 16 equals 0. What I've done, instead of writing that equation, I've just drawn it right here. I have 16 coming up. I have to have 16 in the y coming down. Now, for that to be coming down, this arrow has to be going that way. Okay? Next, I know that this is a 3, 4, 5 triangle. So if the y component is 16, the x component is 12. Now, look at FAE. It has an x component of 12 going to the left. Can you see that? Let me draw that for you. There's this 16, 12. That means 12 going to the left. Well, that's the x component of FAE. So this one, which was FAB, obviously has to be 12. Okay, let's go draw these in green on our little score sheet up above. I am not going to draw the total force. I'm just going to draw the x and y components, 16 and 12, and then this one was 12. Now, I'll do what I did before, draw the opposites there, 12. And again, I'm just keeping track of the x and y components. Now, later, we can get the total by doing Pythagoras theorem. But for now, let's just do the x and y components. So next, it's pretty obvious we can do joint E pretty easily. Let's do that one next. Okay, I'm going to draw the free body diagram for joint E, but I am just going to write the x and y components. So we have that. Okay, that was 16 and 12. You can immediately see that this one, which was FEB, has to be 16 coming down, because this FAE has a y component of 16. Also, you can see that this one, That's FEF. That was FEF. That has to be 12, right? You see how this little 12 component's going to the right? This FEF has to be going to the left. I'm going to put that on our little score sheet above, and let's see where we're at. Okay, so here we go. We got that this one was 16 coming down. That one was 16 going up, opposite. This was 12 coming across, pushing in. That has to be 12 compression in there. We still can't do joint F. There's 3 unknowns, but we can now do joint B. We're repeating the same process that we did before. Okay, here's joint B. I'm going to draw the free body diagram. We've got 12 going down, 16 coming up, 12 coming across, this and this. Okay, this one is FBF and FBC. I'll leave the letters off. I'm running out of room. But again, I'm just going to do the X and Y components. I'm not going to solve for the overall force. Now, you can clearly see that there's 2 X components here, right? There's that X component there, and there's this X component here. There is only one Y component. Okay, I'm going to solve it first. I can see that that Y component has to be 4 going down. And how I did that, let me write out the equation. Sum Fy equals 0. I had 16 going up minus 12 going down. And I need to subtract 4 to make it equal to 0. Minus 4 equals 0. Well, that minus 4 is the Y component of FBF. So that equals FBF Y component. So downward 4. So I drew FBF into the joint, and I made the Y component 4. It's a 3, 4, 5 triangle, so that has to be 3. And then I can now see the mistake we made on the other one. Summing forces in the X direction. Just look at the X component. You have 12 to the left, 3 to the left. This has to be 15 to the right. I think in the other example we had a sign error, and I think we had that as 9 instead of 15. So you can see how this technique helps you not make those types of errors. I'm going to put this up on our little score sheet above, all in green. Okay, so I'm going to draw these in green. That was 4 and 3. And this one was 15. I'm going to put the opposite on the neighbors. So 15 pulling from B is 15 pulling from C. 3 and 4 pushing into B will be 3 and 4. 3 in the X, 4 in the Y, pushing into F. We can now solve for joint C. I'm not even going to draw the free body diagram. Can you see this is obviously 24 pulling up, and that's 15 going that way. I'll draw these opposites over there, 24 and 15. Next we'll do joint D. This one will work, and then we'll do F to double check that everything's okay. Here's the free body diagram for joint D. We have the 20 coming up. We have the 15 pulling away. And then we have this unknown force here. And These had better be the x and y components of 15 and 20, and those had better be in the ratio of 3 to 4, which they are. And this must be coming in compression, because that 15 horizontal is to the left, so the x component 15 is to the right, the 20 reaction is up, and that 20 has to be coming down from, I think that's force FD. Okay, I'm going to put this on the score sheet and come back. Okay, actually we could have just done this without drawing a free body diagram, but just to be complete or to be thorough, let's do this. That was 15 and 20. You can tell by just looking at the picture. 15 to the left, 15 to the right, 20 up, 20 down. And let's draw the opposite of that onto here. 15 and 20. Okay, the last thing we need to do is to make sure that everything adds up to 0 at joint F. I'm going to just do it right here on the picture. Okay, so what we're going to do is add everything in the X. Okay, I'm going to take right as positive. I got a 12 to the right, a 3 to the right, and a 15 to the left, 0. Check Y, up is positive. I've got a 4 going up, a 24 going down, and a 20 going up. That equals 0. Check. Okay, to be honest, when I'm flipping down from these free body diagrams up to the picture, I can't really remember what I did in the free body diagram, but I can actually solve this thing just by looking at these pictures on our little score sheet. And that's going to lead us to our final very shortcut, or the shortest shortcut method I have, and that'll be in the next video. Oh, one last thing we need to do is do Pythagorean's theorem, get the totals, and then I want to go through this score sheet and put T or C if it's tension or compression. So I'm just going to go through a Pythagoras theorem, or this 3, 4, 5. So this one is 3 times 4, 4 times 4, 5. This is 20, 20, 5, 25, 25, and 5. Okay, anything pointing into the joint is in compression. Anything pulling out is tension. Okay? Pulling out, tension, 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 compression. Pushing in, compression, tension, compression. Let's see, compression, compression, tension, compression, compression, tension. Tension, tension, and tension. Actually, the supports, we don't say tension or compression, just in the members. So there you go. That's the final answer.